In this video, let us see about the binary search tree. So hope you remember what is a binary tree. So in the binary tree, the nodes in the tree can have either 0 children or 1 children, or it can have at most 2 children. Now, what is mean by binary search tree is all the nodes which are in the left subtree will have a value which is lesser than the root node. Okay, say that the root node is 50, so all the values which are on the left part of the subtree will be lesser than the root, and all the nodes which are on the right part of the tree will have a value which is greater than the root node. So this is called as the binary search tree. So hope now you can see the difference between a binary tree and a binary search tree. Now let us consider this example. So here is a tree with a root node 39. So now all the nodes which are to the left of this root node will be lesser than the root node. Say 27, it is lesser. And now coming to the node 27, all the nodes which are towards the left of this 27. So say that the left of 27 is 18, then 9. All this will be lesser than this node 27. So here you can see 21 which is lesser, 10 which is lesser, and 19 which is lesser than this 27. So all the nodes on the left of 27 will be lesser. Now come to the right part of the node 27. All the nodes towards the right will have a value greater than the node 27. So this is what we call it as a binary search tree. Now when we move to the right part of the node 39. So say we are moving to the right part of node 39, the value will be greater than the node root node, that is 45. So comparing 45 with 39, 45 is greater, and all the nodes towards the right side of the node 45 will be greater than the root node, that is 45. So 54, 59, 65, 60, all is greater. And the node towards the left of this 45 will be lesser than the root node 45. So this 40 is lesser than the root node 45. So this is what we call it as a binary search tree. Now, this binary search tree are considered to be an efficient data structure when we compare it with the sorted linear array and the linked list. So how do we tell that? So in a sorted array, the searching can be done in the order of log n times. But the insertion and the deletion are quite expensive. The insertion and deletion of element in a linked list. Linked list is easier, but searching for the element in a linked list will take place in order of n time. Now, even in the worst case of the binary search tree, the order that it will take is order of n time to search for the element, and the worst case would appear for the binary search tree when we have a linear chain of nodes. Say that when the tree is left skewed or right skewed. So let me tell you what is mean by left skewed and right skewed. We'll write down the left skewed and right skewed. So what is mean by left skewed and right skewed is when a tree has the nodes always towards its left, right? So the node 39 is a root node, and when you have only left part of the tree, you call it as left skewed. And this is a root node 45 which has only the right part, and if there is only right part of the tree, you call it as a right skewed. And for this the searching operation of the binary search tree will take place for order of n times. So hope you now got what is mean by a binary search tree. Now let us see with one example the construction of the binary search tree. Let us take one example first. Say that we have to create the following nodes. So node 45, 39, 56, 12, 34, 78, 32, 10, 89, 54, 67 and 81. So let us now start constructing the binary search tree. So first, take the node which is given in the series, the first node as the root node. So let us consider, so 45 is a root node. Now coming to the next node, 39. So we have to check out whether 39 is lesser than the root node. Yes, if it is lesser, you have to insert it on the left part of the tree. So 39 is inserted on the left part. Now coming to node 56. 56 is greater, so we'll insert it on the right part of the tree. Okay, fine. Now next is node 12. 12 is lesser than the root node 45, so move to the left. Now coming to 39. So 12 is lesser than 39, so we have to insert it towards its left. So left is 12. Now 34. So 34 comparing with the root node 45, 34 is lesser, so move towards the left. Now compare 39 with 34. So again 34 is lesser, so move towards the left. Now we have node 12. Now compare 34 with 12. So 34 is greater than 12, so we are supposed to place it on the right part of the tree. So it is 34. Now next node is 78. So 78 is greater than the root node 45, so move to the right part. Now compare the node 56 with 78. 78 is greater, so insert it on the right part of node 56. Now next is 32. So 32 is lesser than the root node, so move towards the left part. So then now compare 39 with 32. So here 32 is lesser than 39, so move to this part. Now comparing 12 with 32, 32 was greater than 12, so move to the right part of the tree. Now comparing 32 with 34, so when we compare, 32 is lesser than 34, so we insert it on the left part of the tree. Fine. Now coming to node 10. Node 10 is lesser than 45, so we move to the left part of the tree. Now compare 10 with 39, again to the left. Now with node 12, 10 is lesser than 12, so we insert it in the left part of the tree, the node 10. 89, node 89. So 89 is greater than node 45, so we insert it towards the right. Now 56, compare 56. 56 is lesser than 89, so we have to move to the right. Now 78, 89 compared with 78, 89 is greater, so we insert it on the right part of the tree, it is 89. Now node 54. So let us see, start from the root node. 54 is greater, so move to the right. Now coming to node 56, 54 is lesser, so we have to insert it on the left part of the tree, the node 54. So 54 is inserted. Next is 67. So let us start from the root node. So compare 45 with 67. Insert it on the right part. Now check out with the right node 56. 67 is greater than 56. So come move to the right part of the tree. Now we have node 78. Comparing 67 with 78. 67 is lesser than the 78. So we'll insert it on the left part of the tree, the node 67. The last node is 81. Now let us start from the root node. 81 is compared with 45. So move to the right part. Now 56 compared with 81. Again, it is greater, so move to the right. Now 78 is compared with 81. So 81 is greater, move towards the right. Now coming to node 89. 81 is lesser than the node 89. So we are going to place it on its left. So this is how we construct a binary search tree. And this is the final binary search tree. And there are different operations that can be performed in a binary search tree, such as searching, insertion and deletion operation, which we will see it in the next video.